I wasn't recording. I got to record this. Is it'll actually give me a way to write this expression without any fractions. So this is essentially like saying, hey, when you're solving an equation, you can multiply both sides by the same thing. You can divide both sides by the same thing. I can add something to both sides. That's all I'm doing here. I'm multiplying both sides by the same thing. But because the left side's got a couple of fractions, I've got to make sure I multiply both fractions by that thing. And the reason we do this is that it results in some giant ones. And you might remember that term from Algebra 2. And those giant ones are this factor and this factor. Those are going to just end up being a giant one. And we see that happening in all three fractions. And the beauty of that is that we're left with something that's no longer rational. It's just a linear equation. Well, it's not linear, it's quadratic. But there's no fractions left. So if I write everything else here that we have left, we've got a quadratic expression. I should be able to solve this using my different quadratic techniques. So if you know you're resulting in a quadratic and you have to solve that equation, you've got to get everything on one side. We need one side of this equation to be 0 in order to use quadratic methods to solve. So the first thing I'm going to do here is I'm actually going to add 8x squared to both sides. Now, maybe you could have subtracted everything over to the other side. That would have been okay, but we want to have a positive leading coefficient. In other words, our highest power should have a positive coefficient. So that's what I'm trying to accomplish here. So I get 4x squared plus 8x squared is just 12x squared. And then I'm going to have plus x minus 1 equals 0. And now at this point, we would have to factor to finish solving that. Unless somebody really wants me to factor, I'm not going to, because that was our previous lesson. If you really want me to factor, just put an exclamation point in the chat and I'll go ahead and finish this problem. Let's do something that looks like this. And I apologize, I need to write this down. And you may have seen something like this when you were working on this section of Delta Math. And the reason I'm talking about this one is twofold. First, we've got a mixture of fractions and non-fractions, and I want to address that. And the second, the denominators are not fully factored. So before we can figure out what our common denominator is, we've got to factor it. Okay, so first step, whenever I see an equation or an expression where some of the things in that equation are fractions and others are not, the first thing I do is I try to write everything as a fraction. And I find that just getting everything in fraction form helps it be a little bit simpler for me to figure out, how do these things fit together. So the first thing I'm going to do is write that 1 as just 1 over 1. And remember, you can write any number as a fraction by just writing it divided by 1. Second thing I'm going to do as I rewrite this is I'm going to factor anything in the denominators that I can. So that x squared plus 2x can't necessarily factor that any more like a trinomial, but what we could do is factor out a GCF of x. So the first thing I'm going to do here is factor out that x, and I get x times x plus 2. And then equals, now that negative sign, some of you get kind of, weirded out when you have a negative sign. I just kind of bump it up to the numerator, and then I have x plus 2 in the denominator. And now we're kind of similar to what we did in the previous problem, where I've got to, think about a way to get all the same denominators. When I start comparing the denominators, I see they both, or two of the fractions have an x plus 2. So that tells me this third fraction is also going to need to have a factor of x plus 2. I then notice that this middle fraction also has a factor of x. So that means I'm going to have to get a factor of x in the other two fractions as well. Okay, now at this point, and I'll just rewrite this last step, and then I would leave this one if you wanted to try to finish it on your own to go ahead and do so. I would have x times x plus 2 over x times x plus 2. Resist the urge to change that to 1 because that just puts you back where you started in the beginning. Minus 4 over x times x plus 2 equals And this would be negative x squared times x plus 2. Now's when you could go ahead and multiply by your common denominator to eliminate all of your denominators. And then you'd be able to finish solving this. It will be another quadratic, I do believe. Yeah. And I can tell you, if you have any desire to try to finish this, I can tell you what you should get as solutions. So what you'll get is 2 solutions to start with. You're going to get x equals 1 and negative 2. And again, I'm not going to finish solving this. There's a whole lot of work that happens in there. But you're going to get 2 solutions, x equals 1 and x equals negative 2. Now, the reason I want to talk about this is because we have to check these solutions. So what we're checking for is, do any of our solutions make the original equation undefined in any way? So if I go back up to my original equation, right, I take this 1, if I plug it in up here, and I'm only really concerned about the denominators because the denominators can't be 0, you're going to get 1 squared plus 2 times 1. So we're going to get 3 here. We're going to get 3 here. 3 is fine. No problems there. But when I plug in this negative 2, look, I'm going to get 4 minus 4. That's 0. Negative 2 plus 2. That's 0. That's where our problem is. So I would just say, hey, this actually isn't a solution. The only solution that actually works here is 1. And then that's what you would put into Delta Math. So maybe some of your issues in that section were just understanding why you were getting 2 solutions, but Delta Math was saying there was only 1. So that could be a place where you were having some problems as well. All right. Do you have any other like questions or concerns from that assignment? And if you do, you can either type it in the chat or you can just type a question mark and I'll just have you unmute yourself. So I want to make sure we're... So I just wanted to make sure this was included for you in the video, just so that you can see. I didn't record while we were working through it, but hopefully just having the work there will help you a little bit. Okay, I'll see you guys next time.